All right, so welcome to the third screencast for Chapter 9 on competitive markets for goods and services. This is Section 2, Part B. I'm splitting Section 2 into two parts just so they're a little smaller for you to digest all at once. So what are the learning objectives for this screencast? The first is to be able to show graphically two ways in which an individual firm in a perfectly competitive market can determine the level of output that will maximize their profits. You should be able to explain when should a firm shut down and when should a firm stay in business even if they are incurring short-term losses. Then you should be able to derive the firm's supply curve from the firm's marginal cost curve. And you should be able to derive industry supply curve from the supply curves of individual firms. All right, so let's talk about economic profit in the short run. Economic profit is total revenue minus total cost, right? But recall for us, total cost is opportunity cost. It's the opportunity cost of the firm producing a certain good or service. It's what is the firm not producing? What could they be doing instead? What is the next best thing they could be doing instead of producing this particular good? So it's a little bit different definition than you might see in an accounting class or some other business course. Economic profit is the total revenue less the total opportunity cost of a firm's operations, all right? So you may recall what the total cost curve looks like here. This is a picture from, I think, Chapter 6. And the total cost curve here, it starts here, it intersects the vertical axis here at the fixed cost. So this particular firm in this picture has a fixed cost of $200. Before they can even produce the first item, they incur a cost of $200. And then as they produce more and more, the total cost curve goes up based upon the variable cost of producing each item. And so the total cost curve is just the fixed cost plus this variable cost, which here is increasing at first at a decreasing rate, and then it increases at an increasing rate. And that's where we got increasing marginal returns and diminishing marginal returns, all right? Just to recall what those cost curves look like. So what we can do is we can take that total revenue curve that we had in the last screencast, and we can put it on the same graph with a total cost curve from previous chapters, all right? So what we can see here is for this particular firm, they have a fixed cost of $400. That's why, just above 400 looks like. That's why the total cost curve intersects the horizontal axis here, vertical axis here at 400, all right? So at any level of output, you can find what the total profit is for the firm by just looking at what is the difference between the total cost curve here and what is the difference between the total revenue curve. And that difference is the total revenue, all right? So at 0 units of production, the firm would be making a negative, the total cost would be higher than the total revenue. Well, why would that be if they're not producing any items at all? It's because they've already incurred this fixed cost of $400. So if they don't produce any, they're not making any revenue, and so they're going to incur the total loss of $400, all right? If we move up and the firm starts to produce more and more, here at 1,500 units, we can see the total cost curve and total revenue curve cross one another. Total cost and total revenue are now equal to one another, all right? Well, would the firm want to stop here? Would they want to stop producing here? Well, no. The goal here is not to produce where these curves intersect. The goal is to produce where these curves are as far apart as possible. That's where profit is maximized. So you can see here, if they keep producing, the total revenue curve goes up linearly. It goes up. Every unit gives you more and more revenue. It gives you actually equivalent to the price. Marginal revenue is the price. However, cost has this other shape that we've talked about before. So cost doesn't increase nearly as quickly as does total revenue across this region of increasing returns, all right? Eventually, you'll get to a point where the distance between these two curves is the highest. How do you know where that is? Well, it happens where the slope of the total cost curve, and remember, you can find the slope of a curve by just taking a line tangent to any point on the curve, and that gives you the slope. So at the point where the slope of the total cost curve is equal to the slope of the total revenue curve, that's actually guaranteed here to give you the point of production at which the profit is maximized. The distance between these two curves is the most. So that's where the firm wants to produce. Notice what would happen. What if the firm moved up here to 7,000 units of production? Well, if they did, we would move to here on this curve, and that distance is shorter than this distance here, all right? So the firm would not want to increase production in that way, all right? All right. So how does a firm, now we know where a firm's profit comes from and how they can decide what the profit maximizing level of production is. Our firm is also going to apply the marginal decision rule. They're going to pick the level of output where the slope of the total revenue curve and total cost curves is the same. All right, this is the same marginal decision rule we've talked about before. We just need to translate it a little bit. All right, the slope of the total revenue curve is marginal revenue. That's their marginal benefit. All right, the slope of the total cost curve is marginal cost. All right, so economic profit is maximized where marginal revenue equals marginal cost, or marginal benefit equals marginal cost. This was our marginal decision rule that our consumers used. It's also going to be the marginal decision rule that the firms use. The slope of the total revenue curve is marginal revenue. The slope of the total cost curve is marginal cost. So where are those slopes equal? That's where marginal revenue equals marginal cost. That's where the firm will maximize profit, and that's where they want to produce. So a profit maximizing firm will increase output until marginal benefit of an additional unit equals the marginal cost, just like we saw with consumers before. So the marginal benefit is measured as marginal revenue. All right. We can also look at a graph of marginal cost and marginal revenue. The last graph we looked at was total cost and total revenue, but we could look at a graph of marginal cost and marginal revenue to directly see that the firm wants to produce where marginal cost equals marginal revenue. So it's just a different graph, a different way of looking at the decision rule the firm makes to maximize profits. All right. So here on the left we have the market supply and demand diagram. All right. So the market supply is S, market demand is D. So the market price is found at the intersection. The market price here is 40, and the quantity, the equilibrium quantity in this market is 10. On the right, we have one single firm. This firm is a representative firm. It stands in for all the other firms because every firm is identical, every radish is identical. Those are the two assumptions of this perfectly competitive market model. All right. So over here, you can see that, first of all, the marginal revenue is always the same as the price. In a perfectly competitive market, the price is given by the market. The firms take that price as given, and that is their marginal revenue. It's also their average revenue. All right. So the marginal revenue curve for the individual firm is this blue line here, marginal revenue. All right. So you may recall from before that the marginal cost curve had this shape, and it crosses the average total cost curve at its minimum. All right. That was from a couple chapters ago, but that is the shape of this marginal cost curve. All right. So where should this firm produce? The firm should produce where marginal revenue equals marginal cost. All right. That is this intersection right here at 6,700. All right. Why does that maximize profit? Well, in this graph, we can find the profit by looking at this rectangle here. This rectangle, they're going to make a profit of 14 cents. That's the distance between average total cost and marginal revenue. That's how much they make per unit. And then you just add that up across how many units are they producing. So the area of this rectangle is 938. As it turns out, if you were to pick any other level of production and calculate this profit, it would always be lower than 938. The point where marginal revenue equals marginal cost is the point that is guaranteed to maximize the size of that rectangle. That is the largest economic profit possible. All right. Okay, so now let's look at the flip side. Let's look at economic losses. All right. Well, so here we are at D1, the original demand and original supply. The market price is 40. The market equilibrium quantity is 10. That's the same graph we had before. All right. So marginal revenue here is 40. And remember, our firm was producing where marginal revenue equaled marginal cost. They were producing at 6,700. But something has happened in the market for radishes, and demand has shifted dramatically down. All right, demand has shifted from D1 down here to D2. So that's a big shift in demand. What has that done? Well, the market price has fallen from 40 down to 18. Consequently, the equilibrium quantity in this market has fallen to 2.1 million pounds of radishes. But let's go back to the price and focus on that change from 40 to 18. What does that do for the firm? Well, the firm had a marginal revenue of 40. Now their marginal revenue is only 18. Again, for a firm, marginal revenue equals the price. That is what they get for one more unit is the price of that good in terms of revenue. All right. So now our firm has a marginal revenue of MR2 here at 18. All right. So if the firm were to produce, they still want to produce where marginal cost equals marginal revenue. So where is that? Well, here's the marginal cost curve. Here's the marginal revenue curve. So that intersection is here at 4,444. If they produce there, notice they're going to lose 18 cents. They're going to lose per item this difference between 18 and 23. So they're going to lose 5 cents, a nickel per unit, times the 4,444, and that's their total loss. Why would they produce there? Well, this is actually the point at which they are minimizing their losses. If they produce at any other level, they would actually incur a loss that is bigger. All right. So they're not making profits, they're making losses, but they're incurring the smallest loss possible. Well, why would they want to even produce at this point? Well, if they were to stop producing altogether, they would still incur their fixed costs. All right. So the firm doesn't want to shut down. All right. If they were to shut down, remember they're incurring that fixed cost of $400. All right. That was in the graph before. So if they were to shut down, they would incur the fixed costs without getting any revenue. Here, they've at least gotten some revenue, and they've been able to not have quite as large of a loss. So when would a firm want to shut down? When would the losses be so great that even any fixed costs they incur would not be worth it anymore? It would still be better just to shut down. And this is something known as the shutdown condition. So suppose that the price drops below a firm's average variable cost. All right. This is going to be where a firm wants to shut down. When the price drops below their average variable cost, then the firm wants to shut down. Any price below that will cause them to incur losses that are so big that they don't even want to incur the fixed costs anymore. They just want to shut down and cut their losses because they cannot do any better than shutting down. If they were to continue producing, not only would they lose the fixed costs, but they also lose additional by not covering their variable costs. In the graph we just saw, they were covering their variable cost. So every unit sold gave them a little bit of additional revenue to offset that fixed cost. But if the price drops below their average variable cost, then each additional unit you sell, you lose money. You lose on each unit and you lose on the fixed cost. So here we can see this graphically. Here is we don't have the supply and demand diagram, but assume that demand went even further down. And so the firm finds themselves at a point where the marginal revenue is below average variable cost. All right. So in this case, there's no reason for the firm to produce. If they were to produce, maybe you think they might produce here at 1,700. That's where marginal revenue equals marginal cost. But the loss there is going to be huge. They're going to lose all of their fixed costs, plus they're going to lose for every single unit that they sold. So the shutdown condition is when marginal revenue falls below average variable cost. All right. So from this idea of marginal cost, we can actually derive the firm's supply curve. The supply curve tells us the quantity that will be produced at each price, and that's exactly what the firm's marginal cost curve will tell us. The firm's supply curve in the short run is its marginal cost curve, all right? But this only is true when prices are above average variable costs. Remember that shutdown condition. If prices are below average variable costs, they shut down and they don't have a supply curve at all. But if prices are above average variable costs, then a firm's supply curve in the short run is its marginal cost curve. All right. So here we can see the traditional cost curves. Here I've only put the marginal cost and average variable cost on here. But you can see that this is the firm's supply curve. This part, the part above average variable cost, the part of marginal cost above average variable cost is the firm's short-run supply. And actually, this is where industry supply curve comes from. You just, remember, every firm is identical. So you just take all of the firm's individual supply curves and you just add them all up. Firm 1 supplies so much, firm 2 supplies so much at this price, firm 3 would supply so much at this price, and so that's where the industry supply curve comes from. That's all for this screencast. Next we'll move on to section 3, so I will see you then.